In section 4.4, we will solve equations that involve radicals. The goals of the lesson are to solve equations with radicals and to evaluate equations with radicals. In each of these problems, we will be solving the radical equation. We also need to make sure that in every case, we're plugging those values back in to make sure that they actually work. Sometimes we can get what's called an extraneous solution, which is a solution that we can get, but that when we actually plug it back into the problem does not work and therefore does not represent a true solution to our equation. So here we're going to want to get rid of the square root. To do that, we're going to square both sides. And as we square both sides here, we're going to end up getting 10 squared, which is 100. Now again, before we say that this is the correct answer, we want to plug that back in. Is the square root of 100 equal to 10? Yes. So therefore, that is going to be a true solution. For number 2, again, we can start by squaring each side. That's going to get rid of the square root here and leave us with 5 squared, which is 25 on the other side. Now from here, to get the x by itself, we don't want to be dividing by a 9, so instead of dividing, what we'll do is multiply by a 9 on each side, which will cancel that 9. From here, the 9s are gone on this side. I just get x is equal to 25 times 9, which is 225. Now if I take 225 and I plug it back in for x, well, 225 divided by 9 is going to give me 25. The square root of 25 is 5, so that confirms that that is the correct answer. For number 3, again, square both sides. We end up getting x plus 3 is equal to 2 squared, which is 4. From here, we still want to get the x by itself, so we'll subtract 3 on each side, and that ends up giving us a final answer of 1. Now if I take 1 and plug it back in for x here, 1 plus 3 is 4. The square root of 4 gives us 2, so that does confirm that that's the correct answer. For number 4, here, again, in order to get the v by itself eventually, I first of all will want to isolate the radical. So in order to get that by itself, I've got to get rid of this negative 10. And since the relationship here is multiplication, I will want to divide both sides by negative 10. Once I divide that by negative 10, it's canceled on this side, and I just get the square root of v minus 4 is equal to 6. From here, now it looks like a lot of the problems we've seen already. We're going to square each side here. I get v minus 4 is equal to 6 squared, which is 36. And then finally, to get v by itself, we can add 4 to each side, which ends up giving us v is equal to 40. Now if I take that 40 and I plug it back in to check, 40 minus 4 is going to give me 36. So this is the square root of 36. Well, the square root of 36 is 6. And so negative 10 times 6 does give me negative 60, which confirms that 40 is the correct answer. For number 5, again, we're going to want to isolate or get the square root by itself, and we start by adding 8. I add 8 to each side. I end up getting the square root of 5 minus 5 is equal to 5. Now as I square both sides, I end up getting 5a minus 5 equals 25. From here, to get the a by itself, the first step is to add 5 to each side. I get 5a is equal to 30, and then from there, dividing both sides by 5 is going to give me a is equal to 6. Once again, I want to check that. 5 times 6 is 30. 30 minus 5 gives me 25. The square root of 25 is 5. So now negative 8 plus 5 does give me negative 3, and that confirms that that's correct. And then for 6, once again, we want to get the radical by itself. The relationship here is addition, so the opposite there is going to be for us to subtract this 10 over. As I do that then, I end up getting the square root of 10m minus 1 is equal to 3. Then I'll square both sides, giving me 10m minus 1 is equal to 3 squared, which is 9. From here, to get m by itself, we'll start by adding 1 over. Now I've got 10m is equal to 10. Then I'll divide both sides by 10, and I get m is equal to 1. From here, we can plug that back in. 10 times 1 is 10. 10 minus 1 is 9. The square root of 9 is 3. And then 10 plus 3 does give me 13, so that is the correct answer. On number 7, here we've got square roots on both sides. So I'm going to start by squaring each side, and that gives me 3n is equal to 4n minus 1. From here, I want to get my n's on the same side. So I can either choose to subtract this 4n over, and I would get negative n is equal to negative 1. Or if I don't want to get any negative variables here, I could subtract this over here, which makes it a positive n, and add this one to this side, which makes that a positive 1. And that's what I did here. So now I'm thinking that my answer is just 1. If I plug that in, on this side, I would get the square root of 3. And on this side, I'd have the square root of, this is 4 times 1, which is 4, minus 1. I get the square root of 3. So since the square root of 3 does equal the square root of 3, that is correct. On number 8, we're going to square both sides, which just gets rid of the square root. Now I've got 3x minus 58 is equal to x over 10. From here, I do want to get rid of the fraction. So I'm going to multiply both sides by 10 here. And on this side, I have to give it to both parts. I have to distribute it in. So I get 30x minus 580 is equal to x. From here, I do want to get the x's to one side. Once again, I could subtract this over, which would give me negative 29x. Or if I want to keep those positive, I could subtract this over, giving me positive 29x, and then add this over, giving me positive 580 on that side. And that's what I did here. From here, we can divide both sides by 29. That gives me x is equal to 20. Now I plug that back in and check it. 3 times 20 gives me 60. 60 minus 58 is going to give me 2. So I have the square root of 2 on the left. Over here, 20 divided by 10 is going to give me 2 as well. And that means that I've got the square root of 2 is equal to the square root of 2. Then for 9, again, if I square both sides here, I'm going to get n is equal to 2n minus 6. From here, I can either subtract this over and make it negative n is equal to negative 6, or I could subtract this over and get n and add this over and get 6, and that will be my solution. Now if I plug that back in, I get the square root of 6 on this side, and on this side I've got 2 times 6, which is 12, and 12 minus 6 gives me 6, so I do get the square root of 6 equals the square root of 6, and that's correct. Now for number 10, again, if I square both sides here, I'm going to get n is equal to 4n. Now, if I subtract over the n, I actually get 0 is equal to 3n, or you might get negative 3n is equal to 0. Either way, if I divide by 3, or if I was dividing by negative 3, it's going to give me 0. And when I plug that back in, I get the square root of 0 is equal to the square root of, this would turn into a 0, and that confirms that that is going to be correct. For number 11, we're going to square both sides here. That is going to give us negative 4 plus 4b is equal to b squared. Now, when we have something that's quadratic, something that's raised to the second power here, if we can get rid of that, we'll be able to solve them just like the rest of them. However, if we cannot get rid of that, and I also have a linear term here, we need to move everything to one side, and we're going to want to keep the quadratic part positive. So as I move these two over, I end up getting 0 is equal to b squared minus 4b plus 4. Now at this point, we'll want to factor this. And as I factor that, I get b minus 2 twice, or I can write that as b minus 2 in parentheses squared. From here, I would set each of these factors, which in this case we only have one factor, equal to 0. And when I set b minus 2 equal to 0, I would add 2 to each side, and I do get b is equal to 2. Now once again, we need to check that answer. So I know I'm going to have just 2 on this side. On this side, I've got negative 4 plus 4 times 2. That gives me negative 4 plus 8, which is going to be 4 underneath the radical. And the square root of 4 is going to be 2. So that one does end up working. Then on number 12, here, same thing. I'm going to square both sides. I end up getting a squared is equal to negative 16 plus 10a. Now I bring everything to one side. That gives me a squared minus 10a plus 16 equals 0. Once again, I'm going to factor that. I get a minus 8 and a minus 2. Setting each of those factors equals to 0 is going to give me 8 and 2. Now as I plug them back in, for 8, I'm going to get 8 on this side, and on this side I get negative 16 plus 80. Negative 16 plus 80 gives me 64, and the square root of 64 is 8, so I know that 8 is going to work. Then when I'm plugging in 2, again here I'm going to get just 2 on this side, and over here I've got negative 16 plus 10 times 2, which is 20. Negative 16 plus 20 gives me 4. The square root of 4 is 2, so that confirms that both of those are correct. For 13, once again, we square both sides. Now here we need to be careful. When we go to square this side right here, we have to square everything on this side, but we can't just write x squared and then negative 5 squared. We actually have to think of writing that out twice. X minus 5 times x minus 5 is going to give me x squared minus 10x plus 25 is equal to x plus 1. Once again, since this has a quadratic value that we're not going to be able to get rid of, we're going to move everything to one side. That's going to give me x squared minus 11x plus 24 is equal to 0. From here, I'll factor that. That gives me x minus 3 and x minus 8. is equal to 0. As I set both of these factors equal to 0, I get 8 and 3. And once again, I need to check these. So with 8, when I plug that in here, I'm going to get 8 minus 5, which is 3. On this side, I would get the square root of 8 plus 1, so that's the square root of 9. The square root of 9 is 3, so 8 does balance the equation. For 3, when I'm plugging that in, I've got 3 minus 5, and that's going to be negative 2. Now, right away, I know that the square root is never going to be negative, so I'm already thinking that this is not going to work out, and if I test this, I get 3 plus 1 on this side. 3 plus 1 is going to give me 4. The square root of 4 is 2. So here I would get negative 2 is equal to positive 2. Therefore, that one does not work. I am going to have you guys skip 14. And then as we look at 15, we'll do the same thing we did on 13. We're going to write n minus 7 twice. And as we do that, we get n squared minus 14n plus 49 on the left equals 3n minus 21. Again, having something quadratic here means we're going to move both of these over. That ends up giving me n squared minus 17n plus 70 is equal to 0. From here, I factor to get n minus 7 and n minus 10 is equal to 0. And as I set both of those equal to 0, my solutions are going to be 7 and 10. When I plug 7 in here, 7 minus 7 is 0. And then on this side, I would get 21 minus 21, which is 0, and that's the square root of 0, and that will be equal to 0, so 7 works. And then with 10, I'd have 10 minus 7, so that's 3. And on this side, I've got 3 times 10, so 30 minus 21, which is 9, and that's going to be the square root of 9, which is 3. So in both cases, I did get a true solution. Now read through the following problem and see if you can answer this question. Now in this problem, they're telling us the mass of this one, 825 kilograms, and we can plug that in for m here. They're also telling us the velocity is 26.2 meters per second, so I'll be able to plug that in for v. So far my equation looks like this. Now from here, I'm trying to solve for e sub k. And to get this out of the radical, I first want to get rid of the radical. So I'm going to start by squaring each side here, and that gives me 686.44 is equal to, again, the root is gone, I'm just left with 2 times e sub k over 825. Now from here, my choice is going to be to get rid of the 825 next. So I'm going to multiply both sides by 825. That gives me 566,313 equals 2 times e sub k. Finally, to get e sub k by itself, I do need to divide both sides by 2. And when I do that, I should get 283,156.5. But that's going to be approximately the same thing because I am trying to round to the nearest thousandth. And that's going to give me b. Now for homework, you have 3 sections to look at in Delta Math.